So I hope you can appreciate how cool the things we're about to do are. We're going to say find the volume when the region bounded by the curves is rotated about the x-axis, and the curves are y equals x minus x squared, a parabola opening down, and y equals 0. Well, this is the parabola opening down on the interval 0 to 1, and so that's what we're going to rotate about the x-axis. Now this is an odd looking thing. I hope you can see it. I drew in a sample disc with the red outline and the kind of mauve colored interior, but I just took this and imagined rotating it about the x-axis, and I got something that looks like this. Okay, this is my sample disc that I drew in there. And so what I need to think about is, what's my interval? Well, 0 to 1, that's obvious. What's my radius? Well, the radius of this disk is x minus x squared. And so when I look at what exactly then am I going to be integrating, I got the pi. You know, think about our disk, pi times this radius squared. Well, that's x minus x squared squared. Be careful of remembering that you have to square that, times the thickness, which the dx represents. And so that means we've got to multiply out this, just use a little elementary algebra there, and then integrating each of these parts. Integral that part, x cubed over 3, this one x to the 4th over 4, so that's 1/2 x to the 4th. And integrating this one, x to the 5th over 5, and all that between 0 and 1. Well, great, when I put in 0, everything disappears. When I put in 1, I get 1/3 minus 1/2 plus 1/5. And so that whole thing turns out to be pi over 30, and that's a very small item, as you can tell. You know, the highest it looks like it is at 0.25, and so the 0.25, and it would fit inside a box that was 0.25, actually 1/2 on a side, 1/2 by 1/2 by 1/2. Actually, maybe 1 by 1/2 by 1/2. It would be 1/4, and it would fit inside a box like that, and certainly pi over 30 would do that, because that's just a little bit more than 1/10. So it does seem like a reasonable answer. I always like to check my answers for reasonability, because often I can find mistakes by doing that.